Welcome. This is 10.6. We're dealing with circles and arcs. So 10.6 at the top. And so this chapter, unfortunately, we have a lot of vocab to do. Okay, so the vocab that we're going to need to write is all these right here. Some of these we already kind of know. Other these will be newer terms for us. So write down all these vocab and also have this picture. As you're writing that down, let me explain as we go. So we're talking about circles that we have right here. We obviously know that the point in the center is what we call the center. Diameter and radius, we already kind of know those. Diameter is all the way across the center, going through from one side to another side. A radius is a segment from one endpoint of the center to the other side. So again, this right here, A to P would be our radius, and A to B would be our diameter. And so we know that congruent circles have congruent radii. So if the radii are the same, they're going to be congruent. A central angle is an angle whose vertex is the center. And so the way we label it is right down here in this picture where we say APC. So again, APC, it's a central angle if the angle's vertex is in the center. Again, we label it just like that. So make sure you have all that vocab down. We got even a little bit more that we have right here. Let's have you guys write down, we're going to be talking about arcs. So write down this as well as the picture that we have right here. So an arc of a circle, so there's different types of arcs that we have. One is a semicircle. So if we have a full circle right here, if we take just half of that side right there, that would be a semicircle. 180 degrees, only half of it. A minor arc is smaller than a semicircle, so smaller than a half. A major arc is larger, so it's larger than a half of a circle that you have right here. And we name a minor arc by its endpoints, and a major arc or a semicircle by its endpoints and another point. So again, if you're looking right here, a major arc, you see how we list 3 different points, and we put that little arc sign over the top. Again, when it's only a minor arc, which means it's less than half a semicircle, half of a circle, then we'll only put 2 points, and again, that little line over the top right there. Alright, so we got a little bit more vocab, a lot of vocab in this section. So it says, we're going to write this down in the picture. It says, the measure of a minor arc are equal to its measure of its corresponding angle. So if we look at this right here, if we're trying to find this measurement, if we have this measurement of the central angle, which is 50 degrees, then we know that the arc length right there of RT is also going to be 50 degrees. And then again, as you're writing this down right here, we can also find the measure of the major arc. So I have the major arc right here of RTQR, so that's the blue one right there. Well, if I know a circle is 360 degrees, and if I know that the minor arc right here is going to be 50 degrees, well, all I got to do is take 360 minus the minor arc, and which was 50 degrees, and when I subtract those together, that means that the blue line right here has to be 310 degrees. Okay, so make sure you have that written down. The next one says our arc addition postulate. So same thing as our segment addition postulate before, our angle addition postulate is we can add different things together, different arcs together. So all we're saying is if we take arc AB and we add that with arc BC, that's going to equal arc ABC. Okay, have that written down. This one right here, all you have to do is just have the formula. You should have hopefully done this in previous grades. The circumference of a circle, the formula is either pi times diameter or pi times, or circumference equals 2 pi r, because 2 radius equals 1 diameter. Again, that's the circumference. Circumference means the outside of the circle, like the perimeter of the circle. And the last thing that we're going to write down this whole picture that we have right here, is we're going to find the arc length. So before we were finding like the degrees and stuff like that, arc length is going to show us like the length. And so the way you find the arc length though is the length of the arc of an angle is the product of the ratio. So whatever the arc measure is divided by 360, because again 360 degrees is how many degrees a circle is. So when we divide that, we have AB. So in this case right here, if we're trying to find it of the minor arc, if I take the measurement of AB and I divide it by 360, and then I times that by the circumference of the circle, that's going to tell me that length of AB, which we're looking for. Okay, this will look a little bit clearer as we go through a few examples right now. Alright, here we go. So let's have you guys write down the problem. So what are the minor arcs of the circle A? And again, remember, minor arc, we have a semicircle, which is half, trying to find half the circles that we have right here. And so we have a couple options. Let's just kind of see as we're going through which ones will work and which ones will not work. Okay, so if I look at the first one, PQ, if I'm looking at PQ right here, this does look like that is a minor arc. So again, PQ, yes, those ones look. These ones are all good so far. PS, that looks like less than 180 degrees. Those ones also check off that we have right there. QR right there, that looks less than 180 degrees. QR, those all look good so far. All the same. If we look at RS right here, again, that's less than 180. These ones are good. RS, and then the next one, this one has QS right there. Again, that looks like it's less than 180 degrees. Again, remember, we're looking for the central angle that we have right here, so we go from Q to S that we have right there. So QS, yes, that one is right there. This one doesn't have it, so that one is not included. QS, this one does have it. This one doesn't have it, so we can't include that one. And then the last one is PQR. Again, remember, when we're listing a major angle, we have the three different things. So I have PQR, that's a semicircle that we have right there. So this one would not be the case. So my answer right here would be C. So make sure you have C right there. That is all the one with the minor arcs that I have. Alright, here we go. So let's have you guys kind of write this down as we're going through it. So it says, what is the measurement of BC? So again, BC right here, what is measurement of that? If we know the central angle is 32, remember, those are just going to be the same. So when we're finding BC, it's just going to equal 32. It's the same central angle, and that arc angle are going to be the same. Our question B says, well, what is BD going to equal? Well, again, if we know this is 32 and our arc angle is 32, and CD they told me was 58, again, we're going to use that arc angle measurement. We're going to add those together. So again, all we're going to do is add those two together, just like what it shows us. And 32 and 58 is going to equal 90. So again, BD is going to equal 90. And it says right here, what is the measurement of ABC? If I'm looking at ABC that we have right there, that's a semicircle. A semicircle has 180 degrees. So boom, that's 180. What is the measure of AB? So if I know ABC is 180, and we know that BC is 32, well, all I got to do is take 32 away from 180, and that will give me what AB is. And so this is exactly what it's showing me that we have right here. Again, ABC is 180, BC was 32. All we're going to do is take it away. So we're going to do 180 minus 32, which is going to give us the measurement of AB is going to be 148. Okay. Alright, here we go. Our next problem. Make sure you have this problem written down and draw the picture as well if you can. So it says that we have a car has a circular turning radius of 16.1 feet. The distance between the two cars is 4.7 feet. How much further does a tire on the outside of the car travel than the tire on the inside? So again, if you can see this right here, this 16.1 is that full line, and you can see this 4.7 is just the distance between there. Okay, so again, we're talking just about like the outside of the circle, so we're talking about circumference. Okay, so what I'm going to do is let's look at the outside. Outside, and let's compare it versus the inside. Okay, so again, we're talking about just the outside of the circle, so my circumference right here is going to equal 2 pi r. Okay, and so on the first one, if I'm looking at the outside of the circle, that big circle that we have right there, so to find the one of the outside, we have our circumference, And so we look, we have c is going to equal, and let's just keep it as pi, 2 pi, and our radius is going to be this 16.1. So when we take 2 times 16.1, we're going to get c is going to equal 32.2, and let's leave it in terms of pi. Okay. On the other one that we have right here, to find the radius, well, it didn't give me the radius of the smaller circle, but if I know that over here, if the radius of the bigger one is 16.1, and the radius between there right here, if I subtract that edge right here of that 4.7, well, then we know that the smaller circle's radius is going to be 11.4. Okay, so again, to find the circumference, the perimeter of the circle, 2 pi r, we're going to get 2 pi times 11.4, and so when we get this, we're going to get 22.8 pi. Again, we'll just leave it as pi, and we want to know how much further. So again, what we're going to do is we're going to try and find the difference. Difference means is we're going to subtract. So when we subtract these two, we're going to take 32.2, subtract from 22.8, and we're going to get 9.4 pi, and again, we have feet. And again, just like perimeter that we did with like triangles and rectangles, we don't square or cube it, we just have a measurement unit, feet. Alright, and our last problem that we have right here, so it says, what is the length of shown in red? So we want to find this length that we have. That is the length that we're trying to find. And so we have our arc length that we're trying to find. This is going to equal the, remember, it's the measurement of the arc. You should have had this formula written already. Over 360 times the circumference, 2 pi r. Okay, so if I'm looking at this right here, if this is 90 degrees, then that arc length, the measurement of that arc is going to be 90 degrees. So this is going to be 90 over 360 times 2 pi, and if my diameter is 16, then my radius is going to be 8 that I have right here. So again, 90 over 360, I simplify that. That's going to simplify to 1/4 times 16 pi. And again, what I'm going to do is I'm going to multiply these together. This is going to give me 16 over 4. 16 divided by 4 is going to give me 4 pi. Again, kind of a lot of vocab, a lot of different stuff right there, but I think we should be able to get it. Alright, see you guys soon.